Pearson's chi-square test and Fisher's exact test in Stata. Let's start with Pearson's chi-square test in Stata. Let's revisit a slide from the video about Pearson's chi-square test, Part 1 Introduction. Suppose we want to investigate whether a new vaccine effectively prevents influenza. To study this, we conducted a triple-blinded, randomized controlled trial, where the investigators, clinicians, and analysts remained blinded throughout the study. A total of 400 participants met the inclusion criteria and were randomized into two groups. 100 participants received the placebo and 300 participants received the vaccine. At the end of the study, 50 out of 400 participants contracted influenza. Therefore, the overall probability or overall proportion of influenza equal to 50 out of 400 equal to 0.125. Because the study was blinded, it's unknown how many cases of influenza occurred in the placebo group and how many cases of influenza occurred in the vaccine group. After the table was opened, the following table shows the observed numbers. Based on the observed numbers, we can calculate proportions of influenza for the placebo group and for the vaccine group. We would like to conduct a Pearson's chi-square test. The non-hypothesis two groups are independent, or proportions of influenza are same between the vaccine group and the placebo group. Alternative hypothesis two groups are dependent, or proportions of influenza are different between the vaccine group and the placebo group. Carry out Pearson's chi-square test to get a p-value. Based on the p-value from Pearson's chi-square test, we either reject the null-hypothesis or accept null-hypothesis. If the p-value is smaller than 0.05, which is significant at the 0.05 level, we reject the null-hypothesis and accept the alternative hypothesis. If a p-value larger than 0.05, which is not significant at 0.05 level, we cannot reject the null-hypothesis. Download the data and do file. You can download the data and do file used by this video. Go to the web page, find the downloadable file on chi-square test used by YouTube channels. Afterwards, you can try everything out yourself. Let's go through Pearson's chi-square test in Stata. This is the command line carrying out Pearson's square test in Stata. Texts in blue are either Stata command or options defined by Stata. Text in black or green are variable names. Tab is a Stata command tabulate. Vaccine is the row variables. Influenza are the column variables. Comma in Stata indicates anything after the comma is option. The option expected is to report expected numbers. The option chi-square is to report Pearson's chi-square test. The underline of Stata command and option indicates that Stata understands that TA or tab is the abbreviation of tabulate. EXP is the abbreviation of expected. CH is the abbreviation of chi-square. Therefore, the following command line is the same: TA vaccine influenza, EXP CH. Output for Pearson chi-square test. The first line is to open a dataset. The second is command line carrying out Pearson's chi-square test. The table is output from Pearson's chi-square test. Numbers in blue box are the observed numbers. Numbers in the red box is the expected numbers. Here is the degree of freedom. This is the chi-square values. And this is the p-value. In case you are interested in how to mathematically calculate the degree of freedom, the expected numbers, chi-square values, and the p-value, you can watch video on Pearson's chi-square test part 1, Introduction, and part 2, row and column-wise calculations. Below this video, you can find the link. Conclusions based on Pearson's chi-square test. Again, non-hypothesis, two groups are independent, or proportion of influence are same between the vaccine group and the placebo group. The alternative hypothesis, two groups are dependent, or proportions of influence are different between the vaccine group and the placebo group. Pearson's chi-square value equal to 6.8571 with 1 degree of freedom. P-value equal to 0.009. Because p-value is smaller than 0.05, which is significant at 0.05 level. Therefore, we reject the non-hypothesis and accept the alternative hypothesis. Fisher's exact test in state. Again, let's revisit a slide from video Fisher's exact test part 1, background. Suppose due to limited budget and time, instead of 400 participants, 40 participants were included and randomized into two groups. 10 participants received the placebo and 30 participants received the vaccine. At the end of study, 5 out of 40 participants contracted influenza. Because the study was blinded, before the label was open, it's unknown how many cases of influenza occurred in the placebo group and how many cases of influenza occurred in the vaccine group. The probability is equal to 5 divided by 40 equal to 0.125. After the labels were opened, the following table shows the observed numbers. Based on the observed numbers, we can calculate proportion of influenza for the placebo group and the vaccine group. Let's see command for carrying out Fisher's exact test in state. The current command line is the same as Pearson's chi-square test. If we add one more option, exact, Stata will report Fisher's exact test. Let's see the output. Again, first line is to open a dataset. The second line is to carry out Pearson's chi-square test and Fisher's exact test. Numbers in the blue box are the observed numbers. Because the option expected was added in the command line, therefore the expected numbers in the red box are reported. Because the option chi-square was also added in the command line, therefore Pearson's chi-square test were also reported. In the video of Pearson's chi-square test part 3, validity of Pearson's chi-square test. In this example, the sample size is 40 and the smallest expected number is below 5. The Pearson's chi-square test is not a good approximation. Therefore, the option exacted was added in the command line. Both two-sided and one-sided Fisher's exact tests are reported. If you are interested in the difference between two-sided and one-sided p-value for Fisher's exact test, please watch the video Fisher's exact test part 5, two-sided and one-sided p-values. Conclusion based on Fisher's exact test. The non-hypothesis, two groups are independent, all proportions of influenza are the same between the vaccine group and the placebo group. Alternative hypothesis, two groups are dependent, or proportions of influenza are different between the vaccine group and the placebo group. Fisher's exact test p-value equal to 0.584 because p-value larger than 0.05, which is not significant at 0.05 level. Therefore, we cannot reject the null hypothesis. This is the end of the video for Pearson's chi-square test and Fisher's exact test in state.